Spectroscopy is really a method that uses light to learn about what's going on in an atmosphere, for example, of a planet. Because the terrestrial planets are opaque, if we cannot see into the Earth, then spectroscopy is not going to help us. So spectroscopy is not actually a method that we're able to use to study the interior of the Earth.
But again, using the methods that are available, what can we tell about these boundaries between structures deep down there?
Yeah, great question. So we know that there are different layers inside the Earth. So the Earth is kind of like an onion, right? And as you go deeper and deeper, you get different layers. So for example, we have the crust here on the surface, and those are rocks that have particular composition, particular amounts of silicon in them, for example. And then as you go deeper, we have phase changes that occur, and those cause very sharp boundaries as you get to a certain depth. So for example, at 660 kilometers depth, there's a phase change in minerals, and they're different below that. And then the core mantle boundary, which is about 2,000 miles down, is this huge, distinct region in the Earth. And we can see seismic waves that bounce off that boundary. Because the iron core is liquid, we can see that certain waves can't pass through there. So we can really use seismology to figure out where the different boundaries are in the Earth.
Oh, so we can see what the boundaries are, but we can't look within a given layer to see, again, like what the boundaries of different rocks would be.
Don't think of it as individual rocks kind of all stuck together. Think of it as a sea of rock. It's like one entire layer of rock.
But I would guess different mineral concentrations would constitute gradients within it that would move and convect. And do we have any idea what that looked like? Is it just like an ultra slow moving fluid that has currents within it of mineral concentration?
So we think mostly it's fairly well mixed for a lot of stuff, right? So you have a certain amount of magnesium silicates, you might have magnesium oxides, iron oxides, but it's all sort of mixed. And we can't really see individual boundaries between those with these methods. It's more that we can tell from the density how much of each of those are down there. And sometimes you can a little bit from the composition, but it's mostly that we're seeing these phase changes. We're seeing when perovskite, for example, which is a magnesium silicate, changes from one crystal structure to another.
Well, I know it's funny. We literally are scratching the surface of the Earth. That's all we can do. It's just so deep. But, even the really deep boreholes, could they be used for anything? One that went like 10, 12,000 feet deep. Has anyone thought about setting up instrumentation along the length of these like super deep boreholes to do some studies to see what we can figure out?
Absolutely. And in my book, What's Hidden Inside Planets, we actually talk about what we've learned from, for example, the Kola super deep borehole, which has gone the deepest inside the Earth's surface. So about 8 miles down. So you can learn about things. You can learn about what the temperature is like as you go down. And that tells you a little bit about what the temperature structure will be like deeper in the planet as well. We can learn about some of the phase changes that happen in the crustal part of the Earth, the outermost layer of the Earth. We've really studied that. We haven't yet gotten to the mantle. We can't dig down to that next layer. So that's really been the challenge, but those are very useful. There's another related way that we can kind of learn about the deep interior, and that's that once in a while, we're very fortunate that diamonds come to the surface of the Earth from deep inside. And diamonds are kind of cool, not just because we like them in jewelry or because they're really great in actually scientific instruments, but diamonds sometimes have impurities in them. So little bits of liquid or other mineral that's stuck in the side of them. And because it's stuck inside of them and diamonds are so hard, when they get to the surface, the material doesn't decompress that's inside them. And so we can also learn a little bit about what the materials are like deep inside the Earth by seeing these inclusions, these things that are stuck in the middle of diamonds when they come to the surface.
So what are some things that have been observed and inferred?
Yeah, so one interesting finding is that there's actually probably a significant amount of water deep inside the planet. So this has been a really open question for Earth is, we know how much water there is near the surface. We can measure how much water is in the oceans and the atmosphere, but how much water is there deep inside the Earth, right? And it's really hard to tell that. But when we have some of these diamonds that come up, we have found diamonds that we know come from fairly deep inside the Earth into the mantle that actually have water in them. And we can use that to kind of infer how much water is inside the Earth. Now, the reason that's important is because the Earth constantly recycles itself through plate tectonics. So when we have volcanic eruptions bringing material from the interior to the surface, it actually brings up volatiles like water. And we think, in fact, this is how we got a lot of the water onto the surface, right? So it's really important to understand how much water is deep inside the planet because eventually that water gets to the surface.